Our session will begin with Mr. Bhartesh Bohra and Hemant Kumar from Amdocs, and their topic will be AI driven 360-degree stream automated testing. I would like to invite them to take the stage.
And thank you for giving us this opportunity. Myself, Bhartesh Bohra, and with me is Hemant. We both are from Amdocs. And our topic for today is AI driven 360-degree stream automated testing. So, just to give a brief intro about myself, I am a software test automation manager in Amdocs with around 15 years of experience. And with me is Hemant. He is an automation test specialist. And both of us have this, you'll say, hobby of problem solving and implementing automation wherever it's applicable. So this time we picked up with the criteria of end to end automated stream testing. What it means and why we chosen this, I'll explain in detail. So what is being an automation test manager and into the automation field for so many years, why we chose this problem or what is the problem? So right now with with the onset of OTT and all these streaming platforms, there is a huge business opportunity and these markets are captured, growing day by day. And I was reading around an year back that in India there are 40 plus streaming providers, right from Hotstar to Disney to all the big names. And this presents a great business opportunity, and with this opportunity there lies an opportunity for testing also. So all these services, all these streaming applications which are going live, they have to go through a thorough round of testing. And as of now, there is no tool or no utility or no service available which will do end to end testing of this solution, right from beginning ingestion of the content till the absorption or consumption of the content. There is no automated end to end solution in the industry as of now. So that was the problem which we wanted to solve. And the purpose is to come up with a 360-degree solution which will give end-to-end video streaming testing. And on top of that, we wanted to leverage the cutting edge technologies like machine learning, automation, RPA, and AI into it. So this was the problem, and the solution is to use to use the cutting edge solutions and technologies to solve this problem of end-to-end video streaming and testing. Moving ahead. So what we basically do when we test the content quality services, so we there is a huge gamut or huge variety of testing which can be done when we talk about the streaming and streaming testing. We can do application testing on device, integration testing of this, installation testing, load testing, performance testing, usability, security, compatibility. All these are the different range which we are covering or which we are trying to cover in our solution. How it starts? It starts from content creation, then it goes to ingestion. Ingestion means uploading, and content processing and management means uploading all that content onto the cloud and then processing, then delivering it. And after that, consumer analytics. What is the consumer behavior? So we are analyzing that also. And then content consumption, how it is getting consumed, whether it is meeting the criteria, all the benchmark indices, all the parameters, bit rate or lag or time, all these things which we are doing. So that is a journey of OTT platform. What validations we are doing? We are doing input media validation. Then we are doing the transcoded media validation. When it is uploaded, then it is uploaded into the form of transcoded media. So that validation we are doing. Other than that, we are doing side asset validation, microservice enablement, load, security, performance. So all these kind of things we are testing. Different solution features for video testing. So like I said, what are the features, and each feature come up with a matrix or score, and together this with this algorithm we are coming up with our own golden number, which is giving the the quality of service, or which is giving the level of service what is getting provided. So for configuration, we have video play, app elements, STB, all these configuration related testing we are doing. Then quality of experience or monitoring, that how much is the buffering rate, how much time the screen stream is unavailable, frozen screen, all these kind of testing we are doing. Like I was talking about the different matrices, that what is the blockiness, how many frames are getting skipped, how many times it is getting frozen, then streaming score, all these performance check, then localization, that whether if all the localization, if it is based on the specific device or specific, wherever the consumer is absorbing. So all these localization testing, everything we are measuring, and then we are coming up with our own score, which gives the level of or the quality of the service. This is a service level layer, and in this we have utilized the robot framework, which we developed over the Python. So that is our in-house framework which we have developed, and in this we have utilized the APM and other freewares wherever we can plug in. How it works, what is stream automation and how it works? So basically, it is a complete CI/CD pipeline. So it starts with uploading the code, and then pulling the code from Git, then scheduling or auto triggering the build from the Jenkins, and after that, uh, it is about the framework. So we have BDD layer, we have the framework layer, then we have the driver layer, and after that we have the reporting layer. We will go into the depth of how we are doing it in the further slides, but this is just a high level framework overview. And then afterwards, it is getting connected to different kind of devices, like it could be computer, it could be mobile, it could be TV, and all this we are measuring the quality of service, and accordingly we are coming up with the score. Like I said, what is our approach? Basically, this is an end-to-end automated testing what we are doing. We are implementing the automation, test automation here, and like I said, it is a continuous integration CI/CD pipeline we have implemented. The automation framework is BDD based, behavioral driven, and here we are using the iterative approach. As and when we are checking in, then every time if there are any updates into the code, this is automatically getting downloaded. And AI and ML, this we have used into multiple places. Like I was saying, that the analytical behavior of the consumption, um, which programs or which the videos customer is watching or consuming more, these kind of analytics, or what is his areas of interest, these kind of analytics we are predicting via machine learning algorithms. As well as we are this is like we were saying in the last slide, if we'll go, this is platform agnostic. So it does not depend that where you are consuming. Our framework automatically implements based on the end device where it is getting consumed. So here also we utilize the machine learning framework. So these are the areas where we have implemented machine learning. Moving ahead, so this is our framework. Hemant, you would like to explain about this slide?
Yeah. So in normal automation framework that we usually have, for the device automation is basically not loosely coupled, I'll say. So what we have done, we have the stream of services of the devices, which are being segmented into different, I'll say, chunks, or the components like the IoT, or IoT applications, or the streaming applications, or the voice packets automations. And then if you can maybe mention it, in order to have this code based as a intelligent enough to identify which particular driver it is called for. So let's suppose if I have to do the testing of Steam, the driver itself will identify, okay, these are the test cases that needs to be executed for the stream or the device app, or the compatibility or the performance is enough. So there is an intelligence in that particular code that we have infused in it. And also, the self-healing part of one of the key components that we have in this particular framework. And in order to coming to the major important category that we are presenting is the stream testing. Here we are measuring it in the form of a mean opinion square, which is the key component, or I'll say one of the method that is widely used in order to measure the video quality of any kind of streams or any kind of video packets. So being open in a square is very, very, I'll say, a vague statement. It can be of, can be assessed through two different parts. One is how, which is the objective way, like what is the distorted video and what is the normal video with a good quality. And then with the mathematical measures, you identify what is the difference between that. The second one is the, we call it as subjective, which is very subjective to the human behaviors. Like uh, the quality that I am perceiving is a bit good quality. The you know if it is a bad quality perceived by human, which is conducted by interviews and take samples, and then we have your training data set, you know as a training data set, and train to the model that we have. And in order to execute this, the device, will say 360-degree device solutions, we have created, itself the on-prem labs, which caters both the iOS and the Android devices. We have also framed the cradle. Okay, we can connect multiple cradles devices in the cradle, and you can use any particular streaming sticks that is available in the market. It caters to that as well. So coming to the next slide. Yeah, yeah, Bhadesh,
Yes.
you
Thank
go
you,
ahead.
Hemant. So moving to the next slide, how we are improving the quality of experience. So like I was telling you that what is our solution approach and how we are getting benefited, or how industry is getting benefited. First of all, what is the value we are giving to the program? It is a low cost of testing. Everything is automated, easy to maintain. Like I was saying, that we have implemented machine learning algorithms into the selection of the devices or predicting the consumer behavior, so it is easy to maintain. And then the production quality is quite high, and it is automated. Improved end user experience, we can predict it. And it is lower investment, because earlier there is no end to end. So if I'll categorize my solution advantage, these are basically three advantages. First is the range of the testing what we are doing, right from ingestion till absorption, with integration system, everything we are testing. So that is a versatility. Second, what we can say is that it is end to end automated. And third is we are using the latest technology, so it is fast and easy to maintain. So these are the three basic highlights or features of our automation. And to categorize them: significant improvement in the quality, higher automation coverage, improvised user experience, low investment, high return on investment, and are aligned. It can be scaled, it can be added with the new capabilities, and we can leverage the existing assets. Now, these are the advantages. And then we have tried to give a demo also. We created our solution, and we have recorded a demo, so which we'll play in the next section. So let me go to the demo part. Is this visible? Can I start playing?
Yeah, Bhadesh, let's go ahead.
Okay. So this is our framework. And here you can see that in this, what we will be doing is, in this what we will be doing is we will be starting with our framework, and this will open the video stream from YouTube, and then we will start measuring the parameters. So right now this file is invoking the video on the YouTube. And here we, this basically is to measure the video resolution and speed. That is the main purpose, which is one of the matrices or indices of our uh, framework. So now we are running the test, and this test started now. it will launch the YouTube. And basically it is implemented for one of our customers since last 1 year, where we have put this into the production and we are doing it automation testing for streaming. So this is launching the video from YouTube. You can see we are capturing the logs here. So now the video will start playing, and here we'll check the video resolution and speed. And then as the input, we are taking some manifest files. So what it is doing is it is comparing this actual resolution and actual speed which is happening now with the data which we have used as a training, and from there it is comparing and giving us the results.
So coming, most of us will have the question where we are using and what particular algorithm we are using in the training of this particular data, and using that particular algorithm. So here the MOS being predicted, the score that we are predicting, is being, the parameters that we are using is coding and compression parameters, which can be controlled by amount of quality losses that is happening during the encoding process. The second parameter that is very critical for us is the network parameters that induces the quality of the video, right? They result from the parameterization of the video streams and the transmission in real time, such as what are the packet loss. And there are other parameters like amount of colors, amount of contrast, and image quality. So taking these three as our critical parameters, and based on, you know as earlier I have talked about the objective and the subjective method. The objective, we are not doing the mathematical calculation and bringing out the difference, what is the difference in the image quality, which can be quite a typical response, and quite a tough way to approach it. So what we are doing, based on the subjective way, we are defining the what is the quality of the previous videos. Okay. And then we are training the data. So based on the mean square error and the peak signal to noise ratio, the video quality and the picture quality, and the we call it as a picture quality matrix. We are defining all those qualities and predicting the MOS score. The algorithm that we are using is the ANN algorithm, because this we find it as very the apt algorithm that needs to be, predict the picture quality, or let's say the quality of services or the quality of experience of the video. So what we are doing, the quality of the real video packeted, transmitted over a packet of networks, and we are using ANN model to evaluate the real time how human subjects estimate the video quality. So that's a very critical part where human subjects need to access the quality of the picture. It can be predicted through ANN, neural networks, or if there any particular distortion is happening, if there is a transmission over the network, or if there is any fidelity loss, or the quality is getting degraded. So once the quality affecting parameters are identified, the two extremes, the most frequent occurrence of its values can be measured by using different simulator techniques as well. Like example, if the percent of the loss is expected to vary from 0 to 10, we use 0, 1, 2, 3, 4, 5% in typical values of the loss rate parameters. uh, Coming to the next part, maybe the model we can show, but the model that we are using.
So Hemant, it is not allowing to upload me the PDF file. So I'm not sure
Maybe we
if,
can share the screen. Yeah.
yeah. And meanwhile, we have a question as well. So let's finish in a minute and then we'll go to the question.
Yeah.
I'll do the screen sharing. Meanwhile, you can take the question.
Yeah. Sure. Sure. So the question is, what are the different security testing and the load and performance testing, and how it is integrated into the framework. So the tools that we are using for the security is different matrix, and I can say that we are using the top 10 vulnerabilities. We are accessing based on that, and we are using some of you can say we are implementing brute burp suit as well, IDA pro for the reverse engineering. And yeah, sorry, and for the reverse engineering, and for the performance and the load generation, we are using gatling. That's how we are integrating with the API, Java APIs. And for the machine learning part, we are using pure Python. We are training and generating the test data and with the simulators, and predicting the test cases. Yeah. Sorry, predicting the quality of services.
Is my screen visible, Hemant? Can you see the PDF of our libraries?
Not yet, Bhartesh. Maybe I can go ahead and
Okay,
yeah.
no problem.
Yeah. So this is in the training. What I wanted to show is how well does the ANN is performing for us. And in order to whatever the training sets that we have applied, the results are the correlation coefficient are coming as 0.98%, and the average error that we are getting is 0.25. So once again, I'll say the ANN performance is excellent for in order to accessing the mean opinion square and the video of the quality of the video, or if there is a loss or not. So this is where we are right now. And for the future directions, we are trying to mimic the way in which human subjects perceive the video quality to the destination in the communication network. So this is the work in progress, I'll say.
Okay, so I hope we are able to explain our solution as well as we are able to answer the question which was raised. Any other question or queries which we can solve? Anyone from the jury panel or Shreya? Okay. Okay, there is one more question. When resolution speed of the trained data is compared with the actual, will this be same for the ads that occur in between? So basically in the video, towards the end of the video, if you'll see, it was showing the speed and the resolution both. So it was showing the resolution was normal and speed also it was showing. So basically how it is doing is it is comparing with the already existing manifest file, and based on that it is predicting and giving the results. And will this be same for the ads that occur in between? Yes, it will. We are doing it as well for the ads as well.
And just to add, since we are using in order to test the video and the audio processes right now, we are using the manifest files, the manifest URLs or the MPD files that is there, that will be there for in order to have the streaming videos, I'll say. That is one of the requirement. And the second question is how the reports are being captured. So in order to right now we are integrated with both of the, I'll say, uh, reporting tool, that is Grafana. The Grafana dashboards are being published with the KPIs, MOS score, and then the second one is the ELK stack. So it is integrated with both, with the different tools that we have integrated, and which we are storing in a particular database, and from there it's we are creating a dashboard for the with the MOS squares that is being generated, or the predicted value.
Okay. Any other question? So basically, this tool is a end-to-end automated tool for complete bandwidth of stream testing, and in use for one of our clients since last, I'll say 8 9 months. We are predicting the scores, we are sharing the reports, everything. Any other question? Okay. Okay, so I think we are good.
Thank you so much for that lovely presentation.